So ratios, rates, and proportions is the title of the unit. So we've done ratios, we've done rates, and now we're looking at proportions. So proportions are a statement that show two ratios or rates are equivalent. So we've worked with equivalent ratios and equivalent fractions. So proportions are essentially connecting that. We'll do some work on actually just expanding what we've done to solve for missing values in different places. So examples of proportions could be 3 to 5 equals 9 to 15. That would be an equivalent ratio, so that would be a proportion. $10 per 5 gallons. You went to the gas station and bought some super cheap gas at $10 for 5 gallons. That would be equivalent to paying $2 per gallon. And those would be a proportion or equivalent ratio, or equivalent rates. And so when we're working with these proportions, we often set them up to solve for missing values, and we can use the concept of cross-multiplying to solve these proportions. So when we're working with cross-multiplying, and this gets confused a lot, so do be careful with it and make sure you understand this. When you're given equivalencies in setups of fraction-like, and again, we can set up our rates as fractions. We can do $10 over 5 gallons. We can do $2 over 1 gallon. We can do 3 over 8 or 5 over 8 and 9 over 24 or 15 over 24. If these are part to part, if they're part to whole, then 3 over 5 and 9 over 15. But we can set those up as fractions. So when we have our ratios and rates set up as fractions, we can multiply the numerators and denominators of the opposite fractions. So what I mean is, if we are going to cross multiply in this situation, a over b equals c over d, we're going to cross multiply. So you make this little cross, and this, you don't have to draw these arrows, but we often do just to show what we're doing. We have a times d equals b times c. That's cross multiplying. And now it's important to note, like I said, because people get confused with this, it does not work without the equal sign. So if that equal sign is not there, it doesn't work. If you have 1 over 3 times 2 over 6, you cannot cross multiply these. This is a fraction multiplication. This is not cross multiplication. So you cannot cross multiply those. So working with this and the usefulness of it. Sometimes we have proportions and we have missing values. We often find these in cases with triangles, or if we're trying to scale something up and get those equivalent proportions. So if we have a ratio of 4 to 5 and we want to scale that up, I don't know, maybe this is sand and this is stone. Maybe that's 4 bags of sand to 5 bags of stone. Maybe we're mixing something for a yard feature. Well, our 4 bags of sand, maybe we got 84 bags of sand. So how many bags of stone do we need? Well, it's here. 4 times what is 84? All we need to do is 84 divided by 4. What's that equal to? So we do 84 and we divide that by 4, and that's going to give us 21. So 4 times 21 is 84. So the 5 is going to be multiplied by 21 to get our m. So m equals 5 times 21. which equals 105. So our missing value is 105. So our proportion should be 4 over 5 equals 84 over 105. In the next case, this works with decimals. We have some rates that had dollar values before. These have decimals, so we have some setups with decimals. So here we need to figure out what do we got to do with this x to get to 295 or 94. Well, 1.5, how do we get that to 6.3? We're going to have to multiply it by something because we're getting bigger. Well, we take our 6.3, divide it by 1.5, and I get 4.2. And then, sorry, I went the wrong way on that. My arrow should have been the other way. We're going to divide. We're going to be dividing in this case, in both cases, actually. So we're dividing 6.3 by 4.2 to go back to 1.5. We want to go back from 294 to x. So we're going to divide that one as well. 294 divided by 4.2 is going to give us 0.7. So 0.7 is our x value over 1.5 equals 294 over 6.3. So again, I went the wrong way here. We wanted to go from the 294 to the x. So we're going from 6.3 to 1.5. That was divide by 4.2. So here we had to divide by 4.2 as well. So similar to working with our equivalent rates and equivalent fractions here, just in the case of the situations we're working with, and they're not just general numbers, but generally we're working with our proportion. Our proportions are working with a rate or a ratio.